What if you could see the internet? Not just the websites and apps that you use every day, but the whole network that connects billions of devices across the world. What if you could see your data traveling through a web of wires at the speed of light? What if you could see the sea of routers and switches that guide your data to its destination? Just be patient and you'll see it all. In your mind, the internet might look something like this: an immaterial space to which you upload or download data. But the internet isn't some invisible place elsewhere. It's physical, and it's somewhere. It's a network of all the devices that make it up. But the internet isn't solely a network of devices. Millions of wires connect these devices, from the ones in the ocean to the ones in your living room. Each location on the internet is accessible to every other location on the internet, because there is a pathway between all of them. There are 3 different tiers of paths based on their scale. You can compare the wires that make up the internet to the roads that make up America's transportation system. Tier 1 is the biggest. These are like the interstate highways that cover large distances. They're managed by huge companies such as AT&T and Verizon. Tier 2 are the local highways that connect different counties and neighborhoods, so that you can access the interstates themselves. Tier 3 is everything in between. These are the small streets inside the neighborhood that you use to go to your friend's house. So when you want to travel from your house in a rural county in Texas, you first drive out of your neighborhood street, Tier 3, to get to the bigger road that leaves your town. This is Tier 2. That same road then accesses the interstate highway that is known as Tier 1. A huge distance is covered and then the process is mirrored. 1, 2, 3. What's the fastest thing in the universe? Light. So a signal traveling at the speed of light would be the most efficient, right? That's where fiber optic cables come in. These are network cables that contain glass fibers inside an insulated casing. They transmit data inside of their fibers as light. The huge cables beneath the oceans are fiber optic cables, as they have to travel the longest distances. But not every network is attached physically. Cell phone towers transmit and receive signals from your mobile devices. They're made for doing everything wireless and creating a high level of mobility. They're often placed in places where wired connections are unavailable, such as rural bases in the desert. Okay, so now we've covered some means of transmission, but who is behind everything? ISP stands for Internet Service Provider. This is a company that provides access to the internet. They do this by using different types of connections, such as the fiber optic cable and cell phone towers. Famous examples of ISPs are Xfinity, AT&T, and Verizon. Now you know how everything is connected, but there is still an important question to be answered. How does your data know where to go? The video you're watching right now is physically stored in one of YouTube's data centers as a long collection of zeros and ones. When you request a video from YouTube, the video file is not sent to you as a whole. Instead, it's divided into many small pieces of data, called packets, that are then sent off individually. A packet is just like an envelope. It consists of 2 main parts: a payload and a header. The payload is the actual data that the packet carries, such as a piece of the video file, and the header is a label on the envelope. It contains information about the data inside, such as its source and destination. Each of these locations is represented by an IP address, which is a unique identifier for each device on the internet. Your device has an IP address, and so does YouTube's server, where the video file is stored. But how does your device know YouTube's IP address? You don't type it in when you visit youtube.com, do you? No, you don't. You use a domain name, which is a human-friendly name for a website or service. Domain names are easier to remember and type than IP addresses, but they need to be translated into IP addresses for the internet to work. This translation is done by a system called DNS, which stands for Domain Name System. DNS is like a phone book that maps domain names to IP addresses. When you type youtube.com in your browser, your device asks a known DNS server to look up the IP address for youtube.com. The DNS server then returns the IP address to your device, so it can send packets to YouTube's server. A server is a special type of computer that provides services or resources to other computers or devices on the network. A server can store data, run applications, or perform computations for clients. A YouTube server is a computer that stores and delivers video files to clients who request them. But how do your packets actually reach YouTube server? Since the internet is not a direct connection between your device and YouTube server, your packets have to travel through many intermediate devices, such as routers and switches that act as gateways or junctions between different networks. Routers and switches are smart devices that can read the headers of packets and decide where to send them next. They use protocols and algorithms that determine the best path for each packet to reach its destination. Sometimes, packets can take different routes or arrive out of order, depending on the traffic and availability of the network. But how do you know if your packets arrive safely and correctly? How do you know if some packets are lost or corrupted along the way? How do you know if YouTube server receives your request and sends back the whole video file? This is where TCP comes in. TCP stands for Transmission Control Protocol. It ensures that data is transferred reliably by establishing and maintaining a connection between devices that send and receive data. Let's see how TCP works with an example. Suppose you want to send a message to your friend over the internet. Before you can send your packets, you need to establish a connection with your friend's device. This is done by using a handshake, which is a way of exchanging information and agreeing on some parameters for the communication. A handshake consists of sending and receiving packets with special flags that indicate the intention and status of the connection. Now you've established a connection with your friend's device and you can start sending your packets. As you send each packet, you wait for an acknowledgement from your friend's device, confirming that it received your packet. If you don't receive an acknowledgement within a certain time limit, called a timeout, you assume that the packet was lost or corrupted and you resend it. This is called retransmission. Your friend's device does the same thing when it sends packets to you. It waits for your acknowledgements and resends the packets if necessary. This way, TCP ensures that all the packets are delivered correctly and in order. Let's review what happened when you clicked on this video. First, your device established a TCP connection to a YouTube server by sending packets back and forth over a massive network of cables. These packets were routed and delivered by routers and switches, which make use of the IP address contained within the packets. Then, YouTube sent back packets of data to your device containing the web page and the video file using TCP. Your device then put together all the packets to form the original piece of data and displayed it on your screen. The internet truly grants us the ability to connect with other people at lightning fast speeds. We're now able to learn anything with a couple of clicks. The internet is making us rely less and less on our memory, which in turn makes us more forgetful. If you want to know how to keep remembering the things that are most important to you, you can watch this video about memory.